In today's lesson video, we're going to be talking about parabolas on the coordinate plane. Now, a parabola is a curve that kind of looks like this. A lot of times we call it a U-shaped curve. It's a symmetric curved line on a graph created by a quadratic equation. Okay, a quadratic equation is usually something in this form. Y equals ax squared plus bx plus c. Now, this is actually standard form. And we're going to look at a different form later today, but that's standard form of any quadratic, which would graph as a parabola. And a parabola has other physical characteristics that are helpful in understanding what it means and graphs and things like that. So we're going to look at some of those terms here. Okay, so this is going to be fairly new information. Some of it is going to make more sense right away. Other parts are going to be a little bit more challenging. The first part we're going to look at is the vertex. The vertex is either, it can be called the maximum or the minimum point of the graph, depending on how it opens. We're going to talk about which direction it opens. This parabola opens up. The open part of the parabola is up. So that would make this point here a minimum, which would be the vertex. All right, so that ordered pair would be the vertex. All right, and it's always going to share an x value with what we call the axis of symmetry. All right, and this line here is the axis of symmetry. We're going to skip the word focus for a second, come down here and look at axis of symmetry. It is a line through the vertex of the parabola that splits it into two equal halves, left and right. This is always a vertical line, which makes sense that it goes through the vertex, okay, vertical vertex. All right, and that always has an equation, x equals a number. In this case, if you're looking at this graph, this would be the x value of 5. So the line x equals 5 is the vertex, all right? I'm sorry, is the axis of symmetry. The vertex would be the point 5, and then this y value is at 1. So this vertex is 5, 1. Okay, the axis of symmetry is x equals 5 for this example. And now let's talk about another couple ideas that are really, really important. We have another point inside the graph here that is called the focus, okay? The focus is a point that lies on the axis of, axis of symmetry, and is the same distance from the vertex as something called the directrix. We'll get to there in a second. But this point inside this curve here is called the focus. All right, and that would have an ordered pair of 5, 3. Notice it has the same x value as the vertex, as the axis of symmetry, because it's on the axis of symmetry. And then we've got this line down here called the directrix, okay? So the directrix is a line the same distance from the vertex as the focus, but on the opposite side. It's outside of the parabola, and it is perpendicular to the axis of symmetry, which makes it always a horizontal line, which is y equals a number. And in this case, the y value here is -1, okay? In our example, this would be the equation, y equals -1. So that's a horizontal line. So the directrix and focus are kind of on, they're equal spaces away from the vertex. Okay, and that distance between the focus and the vertex, or the same distance from the vertex to the directrix, is called our p-value. All right, we use the letter p to represent that, and it's the distance from the vertex to the directrix or the focus, and it's the same and is represented by the letter p. So in this case, our distance between the focus here and our minimum point, or our vertex, is a length of 2. Well, you'll notice the same distance from the minimum down to the directrix line is also 2. Okay, so this case, P would be 2. All right, so there's a lot of new terminology here, a lot of things to identify as we are understanding what parabolas look like on the graph. Now, all this is going to come into play and come into focus a little bit for us as we work with our formulas or our equations on the next page. So let's go ahead and turn the page. okay? And this is another kind or another way of writing a quadratic equation. This is called vertex form, okay? Now, as a reminder, standard form was y equals ax squared plus bx plus c, okay? That's called standard form. But this is called vertex form. Okay, vertex form is going to help us out quite a bit because it identifies the vertex just by looking at it. And I'm going to tell you and train you how to do that by looking at an equation like this. Now, you need to understand the letter A here, the letter H, and the letter K represent numbers. So most of these equations are going to just have numbers in those place values. So as we look at this, the vertex is always going to have an X value that is the opposite of the H here. That's our X value. Okay, of the vertex, and a y value that is the same as the k value. Okay, here's how I teach my students to identify this. Okay, the vertex is the point hk, and you might remember this from when we talked about equations of circles. But for a vertex form quadratic equation, we remember this phrase: h lies, k tells the truth. Okay, remember the h value is always the opposite. H is lying about its positive negative value. K is telling the truth. Okay. All right, so this a value in the very front, this letter A represents some coefficient that is going to tell us a couple different things. For one, that a value is going to tell us automatically by looking if the parabola opens up, and we get that from a positive a value. For a positive a, the parabola opens up like this. Or down if it's a negative a. If that number in front is a negative, that means my parabola opens down like this. Okay? All right, the rest of this information comes from other parts of that equation that we have to kind of do some work with. So the directrix is always outside the parabola. It's either above or below, and it's outside. And it's always written as an equation, y equals a number, because it's a horizontal line. Okay? But the focus is a point inside the parabola and has the same x coordinate as the vertex. Okay? And then the period, p or p value, okay, period means the p value. It is the distance the focus and directrix are from the vertex. Okay, it's represented as p. Now, to find the y values of the focus and the directrix, we're going to use this little formula. P equals 1 over 4a. All right, you'll need to remember that. To find the distance they are from the vertex's y value, you have to kind of decide if the parabola opens up or down to know whether to make that a positive or negative p value or a positive or negative a value. So here's some rules you can follow. If the parabola opens up, okay, if the parabola opens up, meaning it looks like this, okay, I want to put some things in here and follow along with me. The focus is going to be inside the parabola, and the directrix is going to be outside the parabola like that, okay? So if the parabola opens up, it's going to look like that. That means we are going to add that p value to find the y value of the focus, and then we're going to subtract that p value to find the directrix. And here's why. From our vertex to go up, we're going to add. We're going to add p. From our vertex to go down, we're going to do minus p. Okay? And I realize I drew that kind of small, but you get the idea. That's when it opens up. Now, the real nice thing about this is when we're using our a value, the positive negative value really takes care of the adding and subtracting in and of itself. We just have to make sure that our drawings, our sketches kind of make sense as we work through these. If our parabola opens down like this, okay, that makes our focus point inside the parabola and our directrix outside the parabola like that. Again, we're working from our vertex here. So if our parabola opens down, then we're going to kind of flip that add and subtract. We're going to subtract the p-value, okay, to find the y value of the focus. And then we're going to add the p-value to find the directrix. And that makes sense if you look at the picture. All right, to find our focus point, we have to go down in the y value. So that's going to be minus p. And to go back up outside of the parabola, we're going to add p. Okay, but like I said, the positive negative values of a really help us out with this, and it'll make more sense when we look at an example. Okay, so here's our first example. All right, what I want us to do as we do this, we're going to make a sketch of this to help understand what it looks like. Okay, so I've got a quadratic function here in vertex form. You'll notice a couple things from our format up here. That number in front, a, is the number 1/2 here, okay? So our a value is the positive 1/2. Since a is positive, that means the direction of opening is up. So my picture is going to look like this. Okay, my sketch is going to kind of look like that. It opens up. That means my focus is inside and my directrix is outside. So since this opens up, that's a positive a value that's going to come into play later. What I want to find first is the vertex, because I can just look at this and look at the vertex. This +3 represents my h, but remember h lies. K tells the truth. This is my K value out there. There's K. So what I want you to remember is, in our vertex, H lies, K tells the truth. So the X coordinate coming from that H is the opposite of +3. The X coordinate would be -3. But the K value here tells the truth. So that is a +3. Okay, that means this point has an X value of -3. Okay, so these are all kind of lined up on this axis of symmetry. X equals -3. But it has a Y value of 3. Okay, so now we got to find the coordinates of the focus and the equation for the directrix. Remember, coordinates of the focus are an ordered pair, x comma y. Remember, the focus has the same x coordinate as the vertex. So since my vertex has an x coordinate of -3, my focus has an x coordinate of -3 because it's lined up on the same vertical line. But to find the y value of that focus, I've got to figure out how much am I adding to this y value 3 to go up to that focus point. And so we do that using this formula, P equals 1/4a. So P equals 1/4a, which means I can take that a value and plug in here. So that's 1/4 times +1/2. Now that's a fraction within a fraction. It looks kind of messy. We're going to convert that. We're going to change that. 4 times 1/2, or half of 4, is just 2. So that's 1/2. So my p-value is 1/2, or a lot of times it's easier to think of this as a decimal, especially when we get some really different looking fractions. So I'm going to think of this as a decimal. This is the decimal value, 0.5. Okay, so to find my focus point, what that means is I'm going to add 0.5 to go up from 3 to the point 3.5. That's my y value of this point, the focus. I already have the x value, it's -3. So the y value is 3.5. Okay? Now we've got to find our directrix. To find the directrix, we take that same p-value and we subtract it. Okay, we kind of do this through our drawing. I'm going to go down from 3 by doing -0.5. Well, when I do 3 minus 0.5 for the directrix, 3 minus 0.5, okay, that's half less than 3. So think about it like a number line. Okay, if I'm counting from 3 back down to 2, I didn't go all the way to 2. I just went halfway. What's halfway between 3 and 2? 2.5. Okay, you're also welcome to plug these into your calculators as long as you get your decimal in the right place. So the directrix is a value of 2.5. Remember, the directrix is a horizontal line, which is always the equation y equals. Directrix is an equation. Focus is a point. Okay? And so that's what we're going to be doing quite a bit of in these first few examples. You're going to make a sketch to help visualize whether you're going up or down, adding or subtracting for each one of these. So let's try one of these together. All right, I've got another function here. I've got y equals 2 parentheses x minus 2 plus 1, x minus 2 squared plus 1. So we're going to make a sketch as we go. The first thing you need to do is kind of follow the same order of steps here. We want to find out the direction of opening. All right, so what I like to do, even before I do this, is to make a list, okay, of my a value, my hk value, okay? So my a value comes from this point right here. That's a positive 2. Since a is positive, this opens up. Like a nice big sketch. And I automatically put my point for my focus, my vertex, and my directrix line. I automatically fill those pieces in. Now, also looking at this, we've got our h comma k. Remember, h lies, k tells the truth. H looks like minus 2, but it's lying. I want the opposite of that, positive 2. K tells the truth, so k looks like plus 1, it is plus 1, positive 1. So let's fill in some of these blanks. The direction of opening was up. The vertex is the point positive 2, 1. I just about wrote the wrong thing. Positive 2, 1. And now to find the focus and directrix, we have to identify P, okay? So this is our next big step. Remember, we're going to use this formula, P equals 1 over 4A, all right? Just know that that's the formula. We're not too worried about where that comes from, just that's my formula, that's kind of my rule to follow to find what P is. So I'm going to take that A value of 2 and plug it in here, and that's going to give me 1/8. Now, I can think of this as a fraction, or I can change it to a decimal. When I change this to a decimal, 1/8 is about 0.125. In fact, that's the exact decimal value. If you do 1/8 and want to find the decimal value, here's kind of what I would suggest to do. Go to your calculator, okay, and just do 1 divided by 8, okay? Clear all that other stuff out. 1 divided by 8, that's the fraction 1/8, okay? .125. So that's my p-value. So you can easily tell kind of what's going on here. This is your focus, the point there. This is your directrix, the line there. This is your vertex there. And I'm kind of going to make a vertical number line here to map those out. Okay, the vertex has a y value of 1. So from 1 to go to my focus, I'm going to go up that p-value. So I'm going to add 0.125. Well, that gives me 1 plus 0.125. That's just 1.25. Sorry, 1.125. So my focus has the same x value, 2, but my y value is now 1/8 more than that, so 1.125. Okay? To find my directrix, remember that's an equation, y equals, I'm going to do 1 minus 0.125. So I'm going to do 1 minus 0.125. And I can go ahead and do that in the calculator. 1 minus 0.125 is 0.875. Okay, so my y value for the directrix is just 0.875. You can put it with the 0 in front or just start with the decimal in front. Like that. Either way is fine. Okay? Let's keep doing examples. So as I look at the next one, okay, I want to sketch this as I go, but the very first thing we identify is our a value and our center, h comma k. We're just looking at the general form of my equation, a parentheses x minus h squared plus k. Well, you can tell the a value here is the fraction negative 1/8. That means since a is negative, this parabola opens down. I'm going to redraw that. Like that. And it doesn't have to be a perfect drawing. I'm not even putting it on a graph. I'm just making a little sketch to organize my thoughts. This opens down because a is negative. That negative 1/8 in front flips everything upside down. So, we still have our vertex here. my vertex would be the point -3, 1, because h lies. Okay, so this vertex, remember I kind of made my little scale here, my vertical scale to find my focus and my directrix. This time the directrix is above this curve and the focus is inside. Okay, there's my focus, there's my vertex, there's my directrix. Okay, the vertex has a y value. We're just looking up and down at the y values of 1. And so I've got to go up to get the directrix and down to get the focus. So we need to do that by finding our p value. So we do 1 over 4a. Well, this time that a value is a -1/8. Now, I'm going to put it in as a negative, but I'm going to explain to you kind of what that does in this case so we don't overthink it too much. When I do 4 times 1/8, what you're really doing is 4 times 1 divided by 8. Okay, so 4 divided by 8 is the fraction 1/2 or 0.5. Well, that kind of looks like this. That's a fraction within a fraction. So what I'm going to do is think of this as 1 divided by -1/2. Now I'm going to do that in the calculator, or I can think of it this way. Divided by -0.5. If I just do that in the calculator, 1 divided by -0.5, I get the whole number, -2. All right, so this equals, it's no longer a fraction. It's the number -2. All right, so my p-value is -2. What that means is I have a distance of 2 between these. And the reason that it's negative is because we're opening down. So I can kind of ignore that negative and realize I'm just going to go up 2 from 1 to get my directrix and down 2 from 1 to get my focus. Because you're technically adding a negative and subtracting a negative still. When you add a negative to find your focus, it's the same as -2. When you subtract a negative, it turns it into plus positive to find your directrix. Either way, this picture kind of helps you know which one's which. So from that +1, when I add 2, my directrix gives me 3. So my directrix, I actually found that one first, is the equation y = 3. But my focus right here, I've taken my 1 and done -2. That gives me -1. Now, the focus, remember, is a point. So my ordered pair has the same x value as the vertex, -3, but my focus now is at -1 on the y value. Let's keep doing examples, okay? This video might take a little bit more time because it's really important that we go through lots of examples to figure this out. This problem looks a little bit different. Notice there's nothing in front of the parentheses. Well, it's not really that there's nothing, it's just that there's an invisible 1. So a is just the number 1, okay? And that's positive, so this is gonna open up. All right, but there's also nothing after the parentheses. It looks like there's no plus k. It's like there's +0. Well, that means the k value, h comma k, gives me a k value of 0. Now the y or the x value here is still the opposite of what you see here. So instead of -7, it's just +7. Okay, so that's my vertex. Vertex is the point 7, 0. That means if I'm kind of going to do my vertical scale, my vertex is at y value 0. My focus is going to be up from that, so it'll be a positive number. And my directrix line will be below that 0, so it'll be a negative number. Okay, so to find that, remember we do 1 over 4a. A is 1, so that's just 1 over 4. And then again, it's helpful if we change that to a decimal. That's 0.25. That means from 0, I'm going to go up by adding 0.25. And I'm going to go down by subtracting 0.25. Well, 0 plus 0.25 is going to be the y value, 0.25. 0 minus 0.25 is the y value, -0.25. So my focus has the same x value as my vertex, has the y value, 0.25. My directrix is the equation y = -0.25. All right, let's move on to another kind of example. All right, this time we're going to be given information and use that information to write our own equations. So we're still going to work with our equations in vertex form. We are still working with y equals a parentheses x minus h parentheses squared plus k. Okay, we're still working with that general form. So there's two different things you can be given. You might be given the vertex and either the focus or the directrix. Okay, or you could be given just the focus and the directrix. We'll get to this one in just a minute. To find the distance p between the focus and the vertex y values, what we need to do is to really look at what a is. Okay, now earlier I gave you this formula, p equals 1 over 4a. Well, the inverse of that formula is a equals 1 over 4p. It works the same way. All right, so to find a, we're going to use our p value to plug into that formula and figure that out. All right, so this time we have to look at what the distance is between the focus and the vertex y values, or between the directrix and the vertex y values. Okay, so we're going to do that, and then we're going to plug in our coordinates from our vertex and write the equation. So we'll come back to this other part, focus and directrix, after we've done an example. So this time we're given a vertex and a focus. All right, now I want you to look at the y values. Okay, the vertex is at 5 and the focus is at 8. So there's two options. Either there's my vertex and there's my focus, or it opens down, there's my vertex and there's my focus. Focus is always inside the curve, so you have to figure out which one of these it is. Since the vertex is at 5, the focus is at 8, that means we go from 5 up to 8, which means that is my example. It opens up. All right, so that is not the one I want to use. So I'm going to go over here and I'm going to kind of make a sketch. Don't worry too much about this as your coordinate plane. We're not actually graphing it. We're just going to make our sketch. Okay, this is going to open up like this. That was nice. It made a nice curve for me. This is my vertex, this is my focus, and my directrix will be down here. All right, well, my vertex, I already have the ordered pair, 4, 5. All right, the focus is the ordered pair, 4, 8. That means the distance between those is 8 minus 5. And we know it's a positive number because this is opening up. 8 minus 5 is 3. That means that's my p-value. All right, that's the first thing we find is our p-value. Okay, so I know that p equals that 8 minus 5, difference between them, which is 3. Then I'm going to use this formula, a equals 1 over 4p. So that's 1 over 4 times 3, which would be the fraction 1/12. And I'm going to leave it as a fraction this time instead of a decimal. So I'm going to write my equation, y equals, instead of a, I put 1 over 12, parentheses, x, and then I just plug in my h and my k. Remember, h lies. So instead of x plus 4, I'm going to do x minus 4, parentheses squared. Don't forget to put that there. Plus my k value. And I know it's plus because k is 5. K tells the truth. And there we have it. That is our equation. So it's a little bit easier, given the information, to write the equation. Let's try another one. This time I give you the focus and the directrix. I want to look at the y values from 1 to 7. Okay, the focus and directrix are not directly on the parabola. Okay, focus and directrix means that I'm giving you the point and the line, and I got to find the vertex from there. There's the focus. There's my directrix line. I've got to find where the vertex is in between there. So first thing I'm going to do is find the midpoint formula, or just the midpoint halfway between the y values, to find the vertex. Okay, I know if my focus is at +1, my directrix is at 7. Okay, if I kind of made a sketch, 7 is up above +1. Okay, so if I'm making my scale here for directrix, focus, my vertex has to be between there. That has to open down. Okay, and I kind of made my sketch over here this time instead of on the graph. That's okay. All right, I know my focus has a y value of 1. My directrix has a y value of 7. I've got to get halfway between there. Well, to find what's halfway between there, you just average them, add them, divide by 2. Okay, so the y value of my vertex, I'm going to do 7 plus 1 divided by 2, because I don't need to worry about the x's. The x's all line up. okay? The x's are going to be the same either way. I know my x coordinate is going to be 2. All right, so 7 plus 1 over 2. 7 plus 1 is 8. 8 over 2 is 4. That means the vertex is the ordered pair 2 for x, 2 for the x value, comma, 4. All right, so I know h is 2, k is 4. Now I've got to find that p-value. Remember, the p-value is the distance between directrix and vertex or distance between focus and vertex. Okay, so from 1 to 4, if I just subtracted those, 4 minus 1, that's 3. But remember, this is a negative 3. P is 1 minus 4, which would be negative 3. I know it's negative because my parabola opens down. Okay, so I'm going to find my a value based on that. A is 1 over 4 times p, or 1 over 4 times negative 3, which in this case would be 1 over negative 12. So there's my a value that goes in front of my parentheses. This time it's negative 1/12. Y equals negative 1/12 parentheses x minus 2. Remember, h lies. Parentheses squared plus k. I found out my k value is 4. K tells the truth. And there's that equation. Let's just keep moving forward. The more examples we do, hopefully the easier this gets. All right, so this time I'm given directrix and vertex again. This one is a lot like number 4 here, but we're given the directrix instead. But again, I want to look at the y values. Okay, I've been given my vertex and my directrix. So if I were to line those up vertically on a scale here, remember, I've got kind of 3 points on my vertical scale: vertex, focus, directrix. All right. So the vertex is here in the middle. I've got to figure out which one's above. Is the directrix above that, or is the focus above that? Well, if this is a y value of 3, the directrix line is 3.5. That's above. So that's my directrix up there, 3.5. So that's my line. Here's my vertex for my parabola, which always opens away from the directrix. So this opens down. So my focus has to be the same distance below 3 as the directrix was. Well, to go from 3 up to 3.5, we added 0.5. So to go from 3 down, we do minus 0.5. Okay, that's my p-value, 0.5. And it'll be a negative p-value because this opens down. Okay, so there's that 2.5 for that focus point. Now, I don't really have to have that for the equation. I really just need the p-value. My p-value is 0.5. The difference, again, we found that by doing 3 minus 3.5. So my a value is 1 over 4 times p, which is 1 over 4 times 0.5. Well, 4 times 0.5 is like doing 4 times a half, or 4 divided by 2. So 4 divided by 2 is 2. So this has, I remember this is a negative a value because we're opening down. Negative 1/2 is my a value. So my equation is y equals negative 1/2 parentheses x, my vertex is already given to me, h lies, so I want to make that plus 2 squared. K tells the truth, so I make it plus 3. There's that equation. All right, let's do one more here, and then we'll move on to the easiest part of the assignment. So again, we're given a focus and directrix here again. All right, I'm given the extreme values above and below the vertex. Okay, vertex is in the middle here. I'm not given that yet, but I know my vertex has an x coordinate of 4 because it's the same as the other point. I've got to find the y value. Well, we want to figure out which one of these is higher and which one's lower, but they're both negative. So remember, we're kind of flipping this. Negative 1.5 is actually higher than negative 2.5 on the y-axis. So the upper point is my focus. All right. So there's my focus point, there's my vertex, and my directrix would have to be down here. So this is going to open up. All right. Okay, so the focus has a y value of negative 1.5. The directrix has a y value of negative 2.5. Well, I've got to figure out what is exactly halfway between those two to know the y value of my vertex. So again, we add them up and divide by 2. We find the average. All right, so for my k value, my vertex coordinate, we're going to do negative 1.5 plus negative 2.5 and divide by 2. When I do that, That gives me the number -2. Okay, it actually gives me -4/2, which is -2. So that is my vertex's k value. 4 -2 then becomes the vertex. So I already know part of my formula. Y equals some a value, parentheses, x minus 4, because h lies, squared, minus 2, because k tells the truth. K is -2. So I've got to find the a value still. Well, this distance between the directrix and vertex is a positive p-value this time, and it's the difference between these two numbers, -2 and -2.5. You should be able to look at that and realize, oh, that's only 0.5 difference, 0.5. So since p is 0.5, I'm going to find my a value by doing 1/4 times p, or 1/4 times 0.5. Okay, well, 4 times 0.5, which is like half of 4, is 2. So that's a fraction 1/2. And this is a positive 1/2 because we're opening up. Okay, so let's go ahead and move on to our final set of examples. Going back to showing you standard form. Okay, this is standard form. Y equals ax squared plus bx plus c. So all we have to do now is take vertex form and try and turn it into standard form, which this is something that is going to use some algebra skills, so kind of follow along carefully here. To rewrite in standard form, you're going to write out the squared portion as like this. If we take x minus h squared, we're going to write that out as x minus h times x minus h, okay? And we're going to either FOIL, if you remember what that means, or just think of it as distributing. We're going to distribute to multiply, okay? Then we're going to simplify like terms, meaning we're going to combine like terms. And we're also going to distribute if we need to. All right, we might be doing some distributing in this step as well. And then make sure the equation is a standard quadratic form. That means we start with our x squared, then our x in the middle, and then our non-x term at the end. Okay, so let's try some examples. This is actually fairly straightforward. So what we're going to do, the first thing we're going to do is rewrite this portion like this. Everything else gets copied down. Instead of x plus 6 parentheses squared, that's the expression x plus 6 times itself. So another x plus 6. Don't forget to copy down the -1 at the end. Okay, that's going to come in later. But we have to understand that x plus 6 squared in parentheses like that is not x squared plus 6 squared. You cannot distribute the exponent like that. It doesn't work. So then we can use what's called FOIL, or we can distribute twice. What that means is we're going to take everything in the first parentheses times everything in the second parentheses. So first I would do x times x, and then x times 6. Then I would do the 6 times x and the 6 times 6. So we're going to list those out and then add up like terms. So first, when we do x times x, that's x squared. Then that x in the very front times the 6 at the very end is a positive 6x. Then the inside 6 times the inside x is another positive 6x. So I add those together. And then lastly, we have the last 6 times the first 6, and that's 6 times 6 is 36. And then we still have our -1 we have to write down. Then we just combine like terms. We've got 6x plus 6x, which is 12x. We also have this 36 minus 1, which is 35. But then the x squared still gets written at the front. Okay? Now this time we didn't have to distribute anything at the very beginning here. There's nothing in front of the parentheses that has to get distributed in. So that is our final answer in standard form. But in the next example, we have a -2 in front. We have an a value of -2. Well, that's going to come into play in a minute. So I'm going to leave that there right now. Then this x plus 3 parentheses squared, I'm going to rewrite as parentheses x plus 3 times parentheses x plus 3. Now there is no k value at the end. I don't have to add anything at the end. So I'm going to distribute x times x, then x times 3, and then 3 times x, and 3 times 3. But I have to keep that in parentheses because this -2 out front needs to be factored in. So I've got my -2 parentheses. X times x is x squared. X times 3 is plus 3x. The other plus 3 times the other x is another 3x. And finally, the 3 times 3 gives me 9. Now, I can combine like terms here. So I'm going to go ahead and do that. Do what's inside parentheses first. X squared plus 6x plus 9 is what is in parentheses now. But now I have to take this -2 and distribute it to all three of those. Notice I didn't do that until the very end. It's the very last thing to do. So I have y equals -2x squared minus 12x minus 18 when I distribute the -2 to everything. Okay? All right, one final example here. Number 3. Again, we want to rewrite this part first. I'm going to keep the 1/2 in front. And I keep my +3 at the end. So when I do my distributing here, I have the 1/2 in front still. X times x is x squared. X times -4 is -4x. -4 times x is another -4x. And -4 times -4 is +16. And then we bring down our +3. Now we can combine these like terms here, but I still have a 1/2 in parentheses, outside the parentheses. -4x minus 4x is -8x and +16. And then I have a +3 at the end. You can't add 16 and 3 yet because we have parentheses. We've got to do parentheses first. And by doing that, we have to multiply everything here by 1/2. Half of x squared gets left as 1/2 x squared. Half of -8x is -4x. And half of +16 is +8. Now I have my +3 at the end, and I can combine that there. So my final answer is y equals 1/2 x squared minus 4x plus 11. And that wraps up our lesson on parabolas.